Hello friends, in this tutorial you will learn how to create an analog meter widget using Tkinter and ttkbootstrap library. So here is an example. So as you can see from this particular window, this is an example of a meter created using Tkinter and ttkbootstrap. So you can press this button which will set this meter to a random value. So here now it is 10. The meter starts from here. This is the 0 and it goes around the whole thing like this. So this is the meter you will be learning to create. So when I press this particular button, it will generate random values and that random values will be shown in the meter. So it will be 84. That means that 84% of the meter is there like that. Now you can set it something like this one. Now here we will also learn about the various parameters that can be used to control the behavior of the meter. Now this is another Tkinter program that is using the meter widget. Here we are using the semicircle meter widget. That means that it starts from 0 and goes all the way to 100 here like this. Now it is used for measuring the CPU percentage usage and the RAM usage. So this is a simple program that we have created using the meter widget and the Tkinter ttkbootstrap library. So you can use the meter widgets to create this type of programs that is used for displaying continuously varying quantities like speed, temperature, CPU usage percentage, etc. I will have a separate video on this particular code, that is how to create this CPU RAM usage monitor. If you want to keep updated about this particular code, just subscribe it. So when I release the video, you will be notified. So now back to the analog meter. So this is our website. You can find all the information regarding the tutorial here. You can also find the source code from here. You can go to contents, source codes, and from here you can download it by clicking here. It will come out as a zip file, or you can browse our source codes from the GitHub. We have a repo here, so I'll go to the particular repo right here. So this is our repo. The link to both our website and the repo is in the description of this particular video. So you can click it from there and get access to the repo. The code is under MIT license, so you can use it for your open source as well as commercial applications. Now here we will teach you how to solve the PIL.Image has no attribute cubic error issue. So if you have compiled some code that has a meter widget, especially the ttkbootstrap widget, and have received an error called as this particular error, then we will teach you how to solve that particular error in this video also. So before we start, we want to make sure that your system has a Python interpreter. So you can check it out by typing Python on the command prompt. So I have the Python here. Now you have to make sure that ttkbootstrap is installed on your Python. So you can use the pip installer, that is pip list ttkbootstrap. So this will list all the packages that are installed with your particular Python installation. So you can check whether it is installed or not. So as you can see from here, I have the ttkbootstrap installed on my system. So if it is not there, you have to install it. So you can install the ttkbootstrap by issuing the following command, that is pip install ttkbootstrap. Here nothing will happen because I already have it installed. So this is the official ttkbootstrap website, and I'm here in the meter widget section. So all the APIs and parameters are listed in this particular page. So this is the code I'll be running. So this code actually has an error which I want to highlight. So and I will also tell you how to rectify that particular error, so that if you're using the code directly from the website, you can use it properly. Now I have this is my IDE. This is the Tony ID. I'll just copy the code directly from the website. So this is the examples I'll be using, this particular one. So I'll just copy it from here and I'll paste it right here. I have the ttkbootstrap installed in this one, so there is no issue in that. So if you are running this, make sure that ttkbootstrap is installed. And now I will run this one. Now as you can see, there is no meter here and we have an error. So I want to highlight the error here. So this is the major issue. We have some issue with something called as img.CUBIC and showing that the attribute error module PIL.Image has no attribute cubic. So we have to rectify that one. So this is because there has been some changes in the library and this thing is using something called as image.CUBIC. So that has been depreciated by the PIL library. So before start running this code, we have to change that. So you have to go here and you have to make sure that from PIL import image, then image.cubic. So this is the depreciated one. So we have to change it to by cubic, image.by cubic. So equal to. So now that issue is solved. Now we will run it again. Now you can see the meter is there and you can use it as you fit. So you can change it here, do everything like this. So by just changing this line, you can use the code directly from the TTK Bootstrap website. Here we are going to create a very simple meter. So I have a basic TTK Bootstrap Tkinter program here. So on the first line, we are using from PIL import image and image.cubic equal to image.bycubic. This is to prevent the error that the image.cubic is depreciated. So after that, we will use the standard TTK Bootstrap. We will import the TTK Bootstrap as TTKB, and we'll also import the constants. So then we create a small root window. So we call it root equal to ttkb.window, and we will use the root.main loop. These are all standard TTK Bootstrap window creation code. Now we will use the meter. So we'll call it as, just give it a name. So we can call it meter. Meter is equal to ttkb.meter. That's it. So this will just create a meter, and we have to add the meter to the, place the meter on the window frame. So you can place meter dot pack. So this will create a meter and place it on the window. So we have to provide some basic parameters for the meter to work. So the minimum amount of parameter is the amount used and the amount total parameters that are used by the meter to display the data. So you can, so first we'll say amount total equal to 100. That means that the maximum value that will be displayed by the meter is equal to 100. And then we'll use amount used is equal to 50. So now the meter will rotate up to the 50% mark. That is the amount used equal to 50. Now these are the minimum parameters that are required by the meter. There are other parameters, but they will be filled, they will be assumed as default. So we will run this particular code. So this is capital M. I forgot that. So this is the basic meter, and you can see that it is under 50%. This is actually a full circle meter. So we can change it from here. Let's make it 90. So it will go all the way over there. So this is what 90% looks like. So this starts from here, that is the top part here, and goes all the way up to 100. 100 is here. Now it's up to 90. So this is showing 90 here, like that. So this is the basic and a very simple meter. You can now add some parameters to make it look different. Now we can also change the size of the meter and the padding between the meter and the window. For that, you have to set the meter size equal to 300 followed by comma. So this will change the size of the meter. So this is what a 300 pixel size meter looks like. You can also change it. Let's change it to 800. So this will create a large meter. Now you can add some padding from the top and the bottom. So for that one, you can use the padding, that option. So you can just say padding equal to, let's say 50. So now the meter is like 50 pixels away from the top and the side of the window. You can also change it to 150. This is what 350 looks like. There is now a gap of 350 pixels from the top and the side. This gap. Now the TTK Bootstrap meter widget comes in two shapes. One is known as the full meter, and the other one is known as the semi-circle meter. The one that I'm showing right now on the display is the full circle one, here the first digit start from here and it goes all the way up to here. This will be the 100, that is the amount total equal to 100. 100 will be here and next to it will be 0, and it will go all the way along like this and reach here. The meter rotates like a clock, that is in the clockwise direction. It increments from 0 to the maximum value. Now there is one more option that is known as the semicircle option. So to control the shape of the meter, that is whether we want it to be semicircle or circle, you have to use a particular variable or a parameter called as the meter type. So here is the meter type parameter. So I'm going to add that here. So here is the meter type equal to, so if you want semi, you can use semi within quotations, and now you can run this thing and the meter will be semicircle meter. You need to have a comma here. So this is the semicircle meter. So the 0 starts from here and it goes all the way like this anti-clockwise towards the 100. That will be, this is what. So I'll just change the amount is equal to 100. So this will look something like this. So as you can see, 0 to 100. I'll also show you the 90. So this is the 90. It starts from 0 to go, it goes all the way like that to 100 is here. So it's 90 here, like that. Now if you want a full circular meter, you can give the option full. So you can just change semi to full. So when you run this thing, it will be a full meter. So you can see it starts from here and goes all the way like this. So this is how you select the meter shape. So by default, it will be full. So I'm going to take it as semi right now. Now you can also change the thickness of the meter dial. That is this one, the blue colored line that is displaying the values on the meter. Now you can also change the size of the meter dial. That is this one, the blue line that is representing the values. So for that, we have to use a variable or a parameter called as meter thickness. So I'm going to increase the meter thickness. So that will be somewhere here. We will use meter thickness equal to. So you have to give some value. So I'm going to give it as 5, comma. Then I will run the code. So the size is actually reduced. Now it's smaller. So you can also go to 1. So it's basically line now. You can also change it to 10. Now this is what 30 looks like. In this way, you can change the thickness of the dial. Here you can see that the dial is continuous. That is, there is no gap between the various strips. So if you want, you can change that. You can make the dial stripped. So for that, you have to use something called as strip thickness. So if you declare strip thickness equal to 0, there will not be any strips. So it will be a continuous line. So if I run this, we will just give it a line that you are seeing previously. Now I want to change the value to 2. So you can see there are segments in the meter dial, and these are strips. By the way, there is no 1. If you use 1, it will not become, it will be for value stripe thickness equal to 1. If you run that particular value, there won't be any meter dial. As you can see from here, there is no meter dial. So the stripe thickness value is available. Value equal to 0 means that there is no stripes. It will be a complete line. While value equal to 1 means that there is no stripe at all. And for value equal to 2, there will be stripes. And henceforth from there, you can increase the stripe thickness. So I'm going to give it like 5. So you can increase the thickness. You can give it 10 if you want. Now I'll give it 20. Like that, you can change it. Now let's say you want to show what your meter represents. For example, if it is temperature, pressure, or speed, or something like that, you have to have some text that is below the meter. So for that, we have to use the parameter called as subtext. So when you use the term subtext equal to let's say temperature. So it will be written below the meter. As you can see, the temperature is written here. It is the default font. So you can change the font of the subtext also. For that, you can use the subtext font. So that will be this one. And you have to give a tuple containing the font, the size of the font, and the type, whether it is a bold or italic or something like that, that you have to give. So I'll give the tuple, that will be this one. And then we'll give it a name. Let's say Comic Sans, comma. And you can give the size of the font, that will be 20 or something like that. Then you can say it is bold or italic. Now you can see that the temperature is shown in Comic Sans and it is bold and the size is 20. You can change the size, let's say 40. Now it is covering the meter dial. Now you can change the font to Times New Roman. So now the font is Times New Roman and the size is 20. You can also change to other fonts like Arial, etc. Now you can see that the color of the text is now slightly gray. Now you can also change the color of the text by using the parameter called as the subtext style. So you have to use the TTK's built-in themes like the primary, danger, etc. So you can find that in their own website, this one. These themes, primary, secondary, success, info, warning, danger, light and dark. This can be used to provide color to your text. So I think we are now using secondary here. I will change into danger. So I'll go here and change the subtext. This is actually subtext style, not font style. So you can see the color has changed into the danger theme. That means it will be red. You can also change it to warning or any of the colors provided by the theme. So now it's yellow. This one, warning. You can also use info or success or something like that. You can see that the color of the meter dial is also blue. You can also change that by using the bootstyle. So it's similar to the subtext style only, but it applies to the meter, that is the dial of the meter, this one. So I'll change it to something else. So we'll go here and we will use the boot style. I will give it as danger. So you can see that the color of the dial as well as the number has changed. Now this is all red, which means that we are using the boot style equal to danger. So you can also use something like success. That will be much better. So it will all be green. So you can see that the color is green. Now we also have an option to control the meter by using the mouse. So you have to make interactive this parameter equal to true. So you put a comma here. So now that we can control the dial by using the mouse. So you can use it. By default, it actually will be false because you don't want to control the meter. Meter will be showing some parameters. So there is an option to control the meter through the mouse also. So that can be done by using interactive equal to true. By default, it is equal to false. So you cannot control it. You have to explicitly make it true to control the dial. You can also provide a side text also. So that is known as the text left. So that text will be here, left 90. So if you want to provide some sort of a information regarding that, you can provide that. There is also a text right. So you go there. So it will come here, right side of the number, that is the 90. So if you want, you can provide some sort of a percentage or some value like that. If you are showing percentage, you can provide percentage here. So it will be 90%. I just want to tell you that all the information that I have already told you is available on our website. You can get it from here. And if you like our content, do like and subscribe. And if you have any doubts, you can put it on the comment section. I will try to explain it. So you can also get the code from our GitHub. Now we need a way to control the motion of the meter so that we can display some useful information. So for that purpose, the ttkbootstrap.Meter widget has some functions. One of those functions is called as the step function. This is the step function. So the step function helps to increment the meter dial by a particular number. Here you will see that the meter dot step and the value is 1. So every time this particular function is called, it will increment the meter, that is the meter dial, by 1. So you can create a clock or a countdown timer or a count up timer, anything, by using this step function. So I'll explain the code. So this is the program that we have created using the step function. So by using this particular button, you can increment the meter. Now it starts from 0 and it will go all the way up to 100. So if you click, it will be 1. Next click, it will be 2, 3, 4, 5, 6, 7, like that. So it will go all the way up to 100. So this is how you use a step function. So you can use it to create a countdown or count up timer. Now I'm going to explain the code. The code is same. You have to import the TTK bootstrap and stuff. Here we are creating the meter. Size is there, padding is there, everything is there. And we are making the interactive is equal to false. So we are not giving that particular value here. And the amount total equal to 100. And we are using amount used equal to 0. That means that when you run this program at first, there will not be any meter because we are starting from 0. And then we are also creating a button. So for that we are using this is the button variable, and we are using the ttk.button and text equal to increment meter. That is the name of the button. And then we will use a command. Command parameter will point to a particular function that will do the increment function. So the name of that particular function is increment underscore button underscore handler. So we have defined it here, this particular function. So when you run the program and when you click the meter button, the code will go into this particular function. Then here it will call the meter.step function. So it will increment the meter by 1. So next time you press the button, it will increment it by 1. So 1, 2, 3, 4, 5, like up to 100. So you're here we are defining the meter as meter. So here meter dot step, and one is the incrementation factor. So I can also give it 2. Then it will increment by 2. So it will be 2, 4, 6, like that. 2, 4, 6, 7, 8, 10, like that. So this is how you use the increment function. So this meter.step function has a strange behavior. Since I have used amount used equal to 0, the step will increment from 0 to 1, 2, 3, 4, 5, 6, 7, like that. So, but if I change it to some other value like 10, so it will start from 10. I'll run the code right now. Okay. Now what it will do is that instead of, so if I press this button, it will go there and it will step by +1. But it actually will do it like -1. Let me show you. So it will go 9, 8, 7, 6. It will actually decrement by 1. Then after it reaches 0, it will increment by 1. Then it will behave normally. So you have to be careful about this particular behavior. So you have to use some logic here to check whether the value you are starting is 1, like that. You can also decrement it, like if you use -1, it will decrement from -1. Now we'll be using another function used to control the meter. This one does not increment or decrement. It is used for setting a particular value inside the meter. Let's say you want to go from 65 to 35 or something like that. You can explicitly use the particular value. That is, if you want 35, the meter position to be 35, you can give it directly 35. For that, you get the set function, that is the set method, this one. So you can use the meter dot amount used variable, that is the amount, that this one. So that is the one that will be controlling the meter dial. So if it is 0, it will be 0. It will be 10, it will move like that. So we'll use the set method to change that value to the number 65. So that is inside a button handler. So if I run this program, the value first will be 10. That will be this one. And when I press this particular set meter value, it will jump to 65. So let's say you're getting this particular value from another source, such as a serial port or something. You can use this function to continuously change the meter value. The function is similar. We are using a button. This is the button. And we are using the text equal to name of the button. And then command is equal to the function which will run when we press the set button. So you can, when you press the button, it will go here and it will set the used variable to 65. You can also get the current value, that is what value the meter is currently at, using the get function. So this will print the current value at which the meter is stuck. So one way is that you can get this particular value. For example, you can create a function that will get values from a separate source. For example, from an Arduino sending temperature values or something like that. And then you can use the set function to set that particular meter. So it will continuously change depending upon the values it receives. So I don't have an Arduino right now. I'll make a program later. So I'll use something else. I'll use a random variable to create some random numbers. So every time you press the button, the dial of the meter will change based on random numbers. So the amount total is equal to 100. That is the maximum value of the meter is 100. So I will be creating a random value between 1 and 100. So for that we have to use the import random module. So we'll import the random module, which is used for generating the random numbers. So we will use the random int. That is, that we will be generating an integer only. You can also generate float between 1 and 100. Then that particular value will be in this particular variable, and we will give this particular variable to the set function of the meter.amountused variable.set. This is not required actually. I just put it for debugging purpose. You can just remove it if you want to. So this function works the same way, but instead of a particular value, a random value will be sent. So I'll run the code. So it start from 10. So every time when we press this button, a random number will be generated between 1 and 100. That will be used to set the amount used variable of the meter, that is this one. So now it is 36. Now I press it again, another random variable will be there, like that. So you can continuously change the meter. You can see that the values are moving here also. That is because we are using the amount used variable dot get. It will get the current meter position and display it here. So you can change it, this particular function with, let's say, get serial port data or something like that. So when every time you press the button, it will get some data from the serial port. Let's say an Arduino is sending some temperature and it will display that particular value. I have not created this function. I'm just showing it for an example. So I'll make a program for that in the later videos. So do subscribe and like my video so I can make these kinds of video. So this is how we use a meter widget from the TTK bootstrap library. This is cross-platform and will work on all 3 major platforms like Linux, Windows and Mac OS. So you can use this to create beautiful meter widgets for displaying continuously varying data. So thank you for watching my video. Hope this will help you, and do subscribe and like my channel. The code is in the GitHub. And I will also leave a link to our website and to the GitHub repo. So do check it out. Thank you.